Hello everyone and welcome to another video in my channel. In this video I have a simple looking but difficult equation to solve. Why do I say this problem is simple looking but difficult? It is difficult to many people because we have three unknown variables and one equation. Since we have three unknown variables, we are supposed to be given two other equations to make the system of equation to be three, where we can solve them for A, B, and C. Now, another problem is that there are infinite number of solutions, and this particular problem is settled by this condition: A, B, C belongs to the positive integers. So this helps us to focus on solving for whole numbers, and this reduces the number of solutions. So we are required to find A, B, and C. What are we going to do to solve this problem? The steps that I'm going to use are very simple and easy to remember. But before I proceed, I would like you to do me a favor. Please like this video, subscribe to my channel if I haven't done so, and also share this video. There are many other videos in this channel that I would like you to check out. And when you do, please leave a like and a comment. I would also like you to share the videos. Please pause this video and see if you can try this question out. When you are done, you can come back and see how I solved it. I would like to read in the comment section what other method you use in solving this problem. Now, to solve it, I am going to rewrite the left hand side of the equation. So it becomes A raised to power square root of B in brackets raised to power 1 over 2 times 2. 1 over 2 times 2 is 1, and 1 times the bracket is the bracket, or 1 times the power is the power. Then minus C will now be written as the square root of C, all raised to power 2, equals to 20. I will now move this 1 over 2, which is the power, inside the bracket. It becomes A raised to power the square root of B over 2 times raised to power 2 minus the square root of C raised to power 2 is equal to 20. So basically what I have is difference of two squares, but I'll make a substitution. Let x be equal to A raised to power the square root of B over 2 and y equals to square root of C. So substituting, the equation becomes x squared minus y squared is equal to 20. Let's recall that we are given that A, B, and C belong to the set of positive integers. So whatever substitution we are making must also be members of these sets of whole numbers. So x, y belong to the set of positive integers. Let us not forget this. Now let's proceed. What we have here is difference of two squared. So I'll expand it into x plus y, then x minus y is equal to 20. So basically we have two numbers multiplying together to get 20. So we can write 20 as 20 times 1 or 1 times 20. Or we can write 20 as 10 times 2 or 2 times 10. Also, we can write 20 as 5 times 2 or 5 times 4 rather, or 4 times 5. But when we look at this bracket, we will see we have x minus y, and each of these other factors will give us positive whole numbers. It then means that x is greater than y. Also, x plus y is greater than x minus y. This condition helps us to eliminate this part of the factors. So we are now left with this part. Now, we are going to equate each bracket to its corresponding factor. We have x plus y is equal to 20 and x minus y is equal to 1. Then x plus y is equal to 10 and x minus y is equal to 2. Also, x plus y is equal to 5, then x minus y is equal to 4. Now, we will solve this set of simultaneous equations to find the value of x and y. And to eliminate them, we'll have to add. So if I add x plus y plus x minus y, I should divide it by 2 is equal to, or is it a member of the set of positive integers? That's a question we need to discover or answer. Now, Let's take for example 20 and 1. If I have 20 plus 1 divided by 2, is it a member of the set of positive integers? 20 plus 1 is 21 divided by 2, that is a rational number, so it does not belong to this set. Also, the same thing with this one. 5 plus 4 divided by 2 is not a member of the set of positive integers, because 5 plus 4 is 9, and 9 divided by 2 is also a rational number. Then we are left with this one, which is 10 plus 2 divided by 2. 10 plus 2 is 12. 12 divided by 2 is 6. And 6 is a member of the set of positive integers. So we see we have been able to eliminate many solutions by making this reasoning. That means that we are going to solve this equation using x plus y is equal to 10, then x minus y is equal to 2. If we add the equations together, this and this will cancel out, giving us 2x is equal to 12, and so x is equal to 6. If we also subtract x plus y equals to 10 from x minus y is equal to 2, subtract it, this and this will cancel out. Y minus y will give us y plus y, which is 2y, and it is equal to 10 minus 2 is 8, and so y is equal to 4. So what we have is x is equal to 4 is equal to 6, and y is equal to 4. Now we see that they are also members of the set of positive integers. So now let's recall that x is equal to a raised to power square root of b, and y is equal to the square root of c. Now in that case, a raised to power square root of b over 2 here, please, over 2 is equal to x is 6, and then y is equal to y is 4, please, write 4 here, is equal to square root of c. Now if I square both sides here, a raised to power square root of b over 2 all squared is equal to 6 squared. I should also square this side, that is 4 squared is equal to the square root of c all squared, where this and this will cancel out, and this and this will cancel out. Then a raised to power square root of b is equal to 6 squared, and then 4 squared is 16, so c is equal to 16. Now I can equate a to 6. A is equal to 6, and then square root of b is equal to 2. If I square both sides, I have b is equal to 4. So a is equal to 6, b is equal to 4, and c is equal to 16. You see, they are all positive whole numbers which satisfy this condition. Now to check if our solution is correct, I'm going to put 6, 4, and 16 for a, b, and c respectively in the original equation. So that is 6 raised to power the square root of 4 minus 16 is c is 16, please, equals to 20. This is 6 raised to power 2 minus 16 is equal to 20. And so this is 36 minus 16 is equal to 20. So 20 is equal to 20. So these are the solutions to this problem. Thanks for watching. See you in another video. Bye.